Hey everyone, geophysicist Stefan Burns here. The 4 astronauts aboard the Orion spacecraft as part of NASA's Artemis II mission have completed their flyby of the moon, exploring the far side of the moon from the safety of their spacecraft, venturing the deepest into space that humans have ever gone. They are now headed back towards Earth with splashdown on April 10th off the coast of San Diego, California. And so I wanted to take an opportunity to show you some of the amazing photos they've taken of the moon, of the far side, of the Earth, Earthset, Earthrise, eclipses, and more. Now that they've reestablished good connection with the Earth, they've been able to transmit these images through the deep space network. And as a result, we have some incredible photos of the moon and more to go through. So with that, let's get right into it. Here we see the moon as taken from the Orion spacecraft on its approach to the lunar flyby. This is a first quarter moon and sunlight is coming in from the right side. Also to the bottom right edge of the moon, we can see the Oriental Basin with this large black patch of ancient lava in its center. This Oriental Basin is a 600-mile wide impact crater ringed by mountains. So this is a big impact that the moon once had. Now we see the resultant feature of that. And here is a gorgeous photo of the moon and of the Earth from later in the lunar flyby mission. We see the waxing crescent moon clearly visible, and then to the right, just about to set below the horizon, a tiny crescent Earth. Just wonderful. And here is another incredible image of the moon taken by the Artemis II crew. And we really see that 600-mile wide impact crater Oriental Basin right there, roughly in the center of the moon to the south. And here we can even see the different rings of the Oriental Basin, one of the moon's youngest and best preserved large impact craters. It is a quite dominant feature. You also see the other numerous impact craters littered across the surface. Again, because the moon effectively has no atmosphere, there's no wind or any sort of atmospheric phenomenon to disturb the features and to erode them over time. The only thing that would do that would be moonquakes. And the moon doesn't have moonquakes all that often. So we really see that the moon had a very dynamic past, and it's still dynamic to this day. There are some reports that the astronauts actually saw some impact flashes during their lunar flyby. And here we see an incredibly detailed image of the surface of the moon showing all the different impact events, the different sizes, ages, and more. And of course you see the Earth there setting below the horizon of the moon. So this is an Earth set, something that you would probably see should you spend any length of time on the moon traversing across the surface. So maybe in 50 years when there's space tourism, this is a site that you could see yourselves. And one thing to note here is that you see the Earth, you see the moon, you don't see any stars. Well, why is that? Let's explain. Let's discuss why we're not seeing any stars in some of these photos. There should be stars in space, and of course there are. Why aren't we seeing them? This is a question that people have asked going all the way back to the Apollo missions. There's still a lot of debate, you could say, around this, but it's a pretty simple explanation. So here we see a photo of the moon and of space. We see that the exposure time on this is only 1/1000th of a second, so 1 millisecond. So the camera opened up its shutter and exposed the sensor to light from its environment for 1 millisecond. Well, in space, there is a lot of light if you're near a star. For example, Earth's orbit, where we are, we receive 1,362 watts per square meter of total solar irradiance. This is all the wavelengths, all the frequencies of light being emitted by the sun. And well, the moon is right in Earth's orbit, so it's receiving effectively the same amount all the time, just like we are. The majority of light from the sun, the light output, photonic output, photons, quanta of light, is ultraviolet, optical, and infrared. Optical is what we see. So there's a lot of visible light in our space environment. On Earth, we of course have daylight, which is when that visible light is hitting the planet. You also have the dark side of the Earth, where it's nighttime. There's always half the Earth in darkness. So that is where there's no light from the sun coming in, unless it's being reflected by the moon, or Venus, or Jupiter, or whatever. And so during a full moon, you will get quite a lot of light because it is reflecting that solar light back to the dark side of the Earth. But if it's a new moon, where the sun and the moon are basically close together in the sky, you're just having darkness. So now that the light level from the sun is greatly reduced, because light photons move in exact straight lines, they don't bend or anything, right? Then you get darkness and you can see the stars. Of course, you're not seeing the stars during the day. Have you ever gone out and looked up and seen stars in the day sky? No. Now, of course, we have an atmosphere, but you wouldn't see them anyways because the sun is so bright. It's the same concept here. Now, here we have another photo taken by the Artemis II crew, 10-second exposure, okay? So now they are pointed out in a way that they are going to see the stars because they dimmed out the entire spacecraft and they pointed in a way that's not getting any of those light photons from the sun, and there you go, tons of stars. No light pollution from human activities, of course. So that shows the difference, but that is 10,000 times longer of an exposure to get that information into the sensor to create that photograph. The light from stars is very, very dim. Of course, you have other settings that are different here, like the ISO and more, but in general, we can really just look at this as an exposure, because if they were to get this nicely exposed in one photo, they need 1/1000th of a shutter, which is what they did. To get the stars, they would need that 10-second exposure, for example. They could composite the images, but this is going to blow out so much, you're not really going to see them there. And again, this is during daytime. So when people are saying, hey, well, I have these photos of a town and then the Milky Way behind it, that's still at night. You're not competing with sunlight. That's the thing. You're not competing with sunlight to get these exposures of the stars. And in space, unless you're on the dark side of some object or planet or whatever, you're always in sunlight, in daylight, effectively, daylight conditions. So that is the explanation as to why we're not seeing stars here. They didn't create a composite image, and this light being reflected off the moon would have been tremendous, such that you wouldn't be able to really create that composite in the first place. Because again, this is daylight conditions that they are operating under.
I wonder, do you still see stars in outer space?
Yeah, I was actually just talking to my crewmates about that today. I've definitely seen stars in outer space, and I was saying I haven't seen as many as I thought I would. So, Reed?
We have so much illumination from the sun on the moon and the earth right now. It is hard at times to see stars. Just like when you walk out in the daytime, you see a blue sky but no stars. We look outside and we see the black space and no stars. But tonight we're going to be pointed into deep space, and we're going to turn out all the lights in the spacecraft for the first time on the mission. And if you give yourself about 20 or 30 minutes, we do this all the time on the International Space Station. Christina and I just have great fond memories of this. You'll start to see the stars, and if you give it enough time, you will see so many stars. It's hard to see the constellations because there are so many stars out there. And the coolest part of those stars is they do not twinkle at all. They are just perfect. They almost look fake. They're just perfect pinpricks of light. So that is our homework for tonight, Jeremy. We are doing that.
We'll take a picture.
And here we see one of the most incredible images taken by Artemis II, and this is a solar eclipse. So the moon is in front of the sun, blocking the majority of light from the sun, and that is why we are able to see some of these stars in this image. You also see that the left side of the moon is slightly brighter, and that is from sunlight being reflected from the Earth. Really incredible what we're seeing here, and it gives you a sense of how light plays around in space and how different planets, moons, objects can then interact together to create these incredible views of the solar system and beyond. And here is sunrise for Orion after this total solar eclipse that they experienced for 1 hour aboard the spacecraft. The sun started to rise over the left edge of the moon. And this is when they were in that period of radio darkness where they couldn't communicate with anybody via the deep space network, because simply the electromagnetic signals, because they travel in a straight line, they were blocked by the solid mass of the moon. Additionally, during this nearly 1 hour total solar eclipse that the Artemis II crew was routed along via the Orion spacecraft, they reported seeing 6 impact flashes. So these are flashes of light created from meteoroids traveling many thousands of miles per hour, smashing into the lunar surface. So they saw 6 impact flashes during their nearly 1 hour total solar eclipse. These are just a few of the photos taken by the astronauts aboard the Orion spacecraft. There are 2 places where they are uploading them for the public to see. One is a Flickr account, the other is a dedicated NASA webpage. I'll link both in the video description so you can look at these photos and more yourself. Thank you all so much for watching, everybody. I've been your host, Stefan Burns. Please smash that like button to help the channel grow. Hope to see you around. Wishing you all well. Have a great day, and I'll see you all in the next video.